Welcome to Mass Q&A session. This is one of the random questions we chose from our Facebook page that we've decided to answer this week. Let's delve in. Cindy has a chocolate box whose length is 12 centimeters, height is 8 centimeters, and width of 6 centimeters. Find the volume of the box. So this question is about volume, okay? Finding the volume of a given figure. And in this case, the figure we are going to talk about is a chocolate box, okay? Which represents something like a cuboid, having a length, having a height, and then a width. So in order to find the volume of such a figure, this is a word problem question. So first, draw the figure. Let's draw something to represent the chocolate box. So we are drawing something to represent the chocolate box. We have a chocolate box. Right. Like a cuboid. Right. Good. And this chocolate box is having a length of 12 centimeters. So length, which is 12 centimeters. It is having a height of 8 centimeters. So a height of 8 centimeters and then a width of 6 centimeters. So width of 6 centimeters. And you are now being asked to find the volume of this figure. Now we know the formula for finding the volume of a cuboid to be volume is equal to the length times the width and then multiply by the height. That one gives the volume of a cuboid. So let's proceed. What is the length of the given figure? That is 12 centimeters, right? So you write your 12 centimeters. You multiply by what is the width of the given figure? That is 6 centimeters. So you write your 6 centimeters. And then what is the height of the given figure? That one is 8 centimeters. So you write your 8 centimeters. So 12 multiplying 6. And then that 2 multiplied by 8 will give you what? That one gives 576. So centimeters times centimeters gives you centimeters square, and then multiply by another centimeters gives you centimeters cube. So we have centimeters cube. So this becomes the volume of the box that was given to you. Our next question from the random questions from our Facebook page is: find the volume of a cube if each edges measures 5 meters. If each edges measures 5 meters. That means we are still on finding the volume of given figures. Okay. Now, anytime you're given a word problem question, deduce the data first. From this one, we are dealing with finding the volume of a figure, so we have to draw the figure. And the figure is what? A cube. So it means it is having all the sizes to be equal. Let's draw a cube. All the sizes should be equal. So assuming this cube is having equal sizes, okay? Not drawn to scale. Right. So we have a cube. We have a cube. And it is having 5 meters at 8 edges. So a cube is supposed to be having 3 lengths, okay? 3 lengths before we can find the volume. So if it was supposed to be a cuboid should have the length, it should have the width, and then it should have the height. Okay, good. That was to be a cuboid. But in that of the cube, we are saying all the edges are equal. So it means that when it comes to the cube, in finding the volume, the length, if the length is 5 centimeters here, the width should also be what? 5 centimeters. And then the height should also be what? 5 centimeters. So per this understanding, we usually say that cube is having all the sizes to be equal, so we can use any of these identities for any of the sizes. So we can say that the length is the width, we can use the height to also represent the width, okay? So let's take it as I'm using 1. I'm taking all these 3 sides as the length, okay? So let me take this one as my L, another L, another L, another length, where this L represents the height, and then this L represents the length, and then this L represents the width. All the sizes are equal, so you can represent them with any identity. Okay, so in finding the volume of a volume of a cube, you multiply the length by the length by the length. If that was to be a cube where we say the length, the width, and the height, because they have to be different identities, okay? But because it is a cube, all the sizes are equal. So we take 3 of the sizes and multiply. That is the length, and the length, representing the length, the width, and the height. Now let's delve in. So all the sizes are equal, so we have 5 meters multiplying another 5 meters multiplying another 5 meters. Let me wrap this one off. I just use it to explain the concept for you. So 5 multiplied by 5 gives you what? 25, right? Multiplied by 5 gives you what? 125. So we have 125 meters times meters gives you meters square. Multiply another meters gives you what? Meters cube. So this becomes the volume of the cube, which is having the sizes to be what? 5 meters each. 5 meters each. The length, the base, the height, okay, produces 125 meters cube for the volume. The next question from Maria is, a water tank is shaped like a cylinder. It is 10 meters tall and has a radius of 5 meters. How many cubic meters of water can the tank hold? And you are supposed to round your answer to the nearest whole number. Now you see, the question is telling you that this water tank is shaped like a cylinder, and this means that you are going to use the means of finding the volume of a cylinder to solve and then find the volume of water that the tank can hold. Okay, so 10 meters as being tall, that is the height, for which the radius is 5 meters, and then you are being asked to find the volume. So first, draw the figure. Let's draw a cylinder. So we have a cylinder. You have a cylinder, and then this cylinder is having a height, okay, a height which is h of 10 meters, and then it is having a radius of what? 5 meters. So from the middle to this side is what? 5 meters. Okay, that is 5 meters. Now we are being asked to find how many cubic meters. That means the answer that you are going to get should be in what? Cubic meters. And indirectly it is telling you to find the volume, okay, of the water that the tank can hold. So the volume of a cylinder is calculated as pi r square h, okay, pi r square h. That is the volume of a cylinder. That is how we calculate for the volume of a cylinder, where the pi represents 22 out of 7, or 3.142, and then the r is the radius, and then the h is the height. Okay, So the pi multiplies the radius square and then multiplies the height. So pi represents what? 22 out of 7. Now over here, take note. If the question says that take pi to be 3.14, or take pi to be 3.142, or take pi to be 22 divided by 7, then you have to stick to that. But if the question doesn't restrict you to use any of those figures, always use the fractional part, okay? The 22 out of 7 to represent the pi. So we have 22 out of 7 multiplying, the radius is what? 5. So we have 5 meters all square, and then multiplying the height. The height is what? 10 meters. Okay, the height is 10 meters. So we have 22 divided by 7 times 5 meters square gives you what? 25 meters square, and then you multiply that by 10 meters. So 22 divided by 7 multiplying 25 meters square multiplying 10 meters gives you 785.7143 meters cube. So that becomes our answer, 785.7143 meters cube. But look at the question. Round your answer to the nearest whole number. Okay, so it means that we have to make sure that the answer is not in decimals but in a whole number and in the nearest whole number. So when you look at this number here, the last whole number in this numbers here is what? 5. Okay, so after the 5, the first decimal point, the first number that you see, that is what you are going to base on to write your whole number. So you see that the first decimal, after the decimal point, the first number here is 7, and that 7 is more than 5. Anytime the number is more than 5 or equal to 5, we will add 1 to the whole number. But if the number is not up to 5, then we leave it. Okay, so you see that the 7 is more than 5, so it means we are going to add 1 to this one, making it the rounded answer. Okay, so when you round this 785.7143 meters cube to the nearest whole number, it becomes what? 7 is more than 5, so we add 1 to it and it becomes, the answer is what? 786 meters cube. So this becomes the volume for the water tank. The volume of water that the water tank can hold, 786 meters cube.